Now, question number 15. A ball is thrown from the ground at an angle of theta with the horizontal and with an initial velocity of u0 for the resulting projectile motion. The magnitude of average velocity of the ball up to the point when it hits the ground for the first time is v1. After hitting the ground, the ball rebounds and at the same angle theta, but with a reduced speed of u0 by alpha. Its motion continues for a long time as shown in the figure. If the magnitude of the average velocity of the ball for entire duration of the motion is 0.8 v1, then find the value of v1 alpha. So this is the question. Here what happened? One ball projected. Here one ball projected by making an angle of alpha with x-axis, and it continues up to entire journey, colliding to ground, and this rebounds continuously. For example, one particle projected like this. Initially, how much angle? This is u0. This is velocity. Angle is theta. u0 is the initial velocity. Again, second time what happened? Second time it had reduced to u0 by alpha. Angle same only. First time projected, after colliding to ground, rebouncing like that moving. In the finally what happens? After moving like this, again after like this, finally coming to rest. So this is my total displacement. So here what I had given, one important point given. In the first time average velocity, magnitude of average velocity in this duration is v1, that is average velocity in the first duration. Again what I had given condition, if the total magnitude of average velocity in the total journey is 0.8 v1, in the total duration average velocity is 0.8 v1. If that happens, then find the alpha. So that is the question. Here u0 by alpha. Again here also given. What about this? u0 by alpha square. Like that velocity reducing. Angle of projection same only. After rebounds also it is moving like that angle. Assumption like that. So we are finding the alpha value. So this is my question. So here what is the u0 initial velocity? Second time after rebouncing, first rebounds, what is the velocity? u0 by alpha. Second rebounds, u0 by alpha square. Like this going, and the u0 by alpha n happens in the ending moment. So from here to here, what is the total displacement? Total displacement by total time. That is called average velocity. That average velocity what you are given? 0.8 v1 given. But what is the v1? In the first parabolic path, after projection when it reaches first time ground, in that case average velocity is v1 given. By using that condition we are finding alpha value. So this is my question. So here what we are finding first? This velocity I don't know, that I am taking u1. So this time also here not given, so that I am taking t1. Similarly here horizontal velocity, that I am taking u2. This is what? t2. Similarly here what is the horizontal velocity? u3. Total time t3. What is the t1 here? Time of flight. So first what I am finding? Total displacement by total time. First I am finding total time. So from here to here this is called what? Time of flight. So from that I am taking one relation belongs to time. After total displacement. Total displacement by total time gives what? Average velocity, and that is equals to 0.8 v1. So this is about this question. Now, what is the formula for time of flight? Time of flight. What is the formula for time of flight? Time of flight, that equals to 2u sin theta by g. That is the formula for time of flight. In the first duration, what is the time of flight? T1. So you write this as T1 equals to 2u. U means initial velocity. What is the initial velocity? U naught. Initial velocity of projection into sin theta by g. This is my first equation. Similarly, in the second case, what is the time of flight? T2. That what I am writing? T2 equals to 2 u naught by alpha. 2u sin theta. Here also angular projection is theta only. By g. So here what I am writing this? You write that again as, this implies T2 equals to, I am writing this as 2 u naught by sin theta 1 by alpha into 2 u naught sin theta by g. Alpha by 1 means 1 by alpha. 1 by alpha. Like this, right? So this value I am writing again as T1. So now what happens? T2 equals to T1 by alpha. T2 equals to T1 by alpha. Because 2u sin theta by g equals to, I am writing T1 according to first equation. Since according to first equation, so second time alpha coming, third time what comes? 2 alpha comes, like that I am writing. So this is T2. Similarly you write T3 equals to, what I am writing? T1 by 2 alpha. If it is 2, here 1 alpha. If it is 3, 2 alpha. What about this fourth? This is 3 alpha. Like this, up to dash dash, infinitive, not n. Coming ground to rest means what? After number of percent is coming to rest. So that belongs to infinitive, not n. So now I am taking total time because we want average velocity. Average velocity equal to resultant displacement. Total displacement by total time. It is moving horizontally also, total displacement. If it is number of directions going, you take resultant velocity. Resultant velocity means what? Resultant displacement by resultant time taking for finding average velocity. Resultant displacement means addition of vectors of the displacements. Okay, now I am taking total time. So that total time that I am taking as T or capital T. Capital T means second time. Time of flight. Ascent plus time of descent, time of flight. The confusion comes, so small t take. Now, so what is the first one here? First one T1 came. Second came T1 by alpha came. Third one T1 by 2 alpha came up to dash dash infinity. Now I am finding total time. So here I am taking T1 common. If you take T1 common, what I am getting? 1 plus 1 by alpha plus 1 by 2 alpha plus up to dash dash infinity. So now this I am comparing with the infinitive GP. GP is in infinity. So in that case we are having one formula for finding S infinitive, that is A by 1 minus R. So that concept we are applying in this case. That concept we are applying in this case. Now you apply S infinity. So what is the formula for that? A by 1 minus R. That equals to A by 1 minus R. Once you compare how it is, you compare this. How? AR square dash dash infinitive. That is in GP. So S infinitive equals to A by 1 minus R. You compare A equals to 1. What is the R? That is the ratio. 1 by alpha by 1. 1 by alpha. Again, third by second. 1 by 2 alpha by alpha. 1 by 2 alpha by 1 by alpha. So, like that we are getting. So, what is that value? That equals to A by 1 minus R. So, the total you are getting as. So, here you take the total we are getting as alpha by alpha minus 1. A equals to what? Alpha by alpha minus 1. So it is not 2 alpha, that is alpha squared. We are getting this as, this is alpha squared. Not 2 alpha here, alpha square I am getting. Like that we had done only second. If you do third, like that we are getting alpha square. So here this is alpha square happens and this is alpha cube happens. Previously what we had done, like that you continue, that comes, alpha square comes. So here what happens? Alpha square like that happens. Now here what happened? What about this? 1 by alpha by 1 means? 1 by alpha. 1 by alpha square by 1 by alpha. Again I am getting 1 by alpha. Second term how we are done, like that third term also if you want to do, you do. Then we are getting 1 by alpha square. Now you apply that formula. Then S infinity what happens? This implies S infinitive that equal to A by 1 minus R. Compare. A equals to 1. 1 by 1 minus R. What is the R value? 1 by alpha. So what about S infinitive? A equal to 1, R equal to, substitute in that. S infinity equal to 1 by 1 minus R. So 1 by LCM alpha, alpha minus 1. So what is the S infinitive? Alpha by alpha minus 1. Okay, you take this is third equation and you take this is fourth equation. This total value I am substituting. What is that value? Alpha by alpha minus 1. So what is the T value? T equals to now what is the total time? The total time equals to T1 into alpha by alpha minus 1. Now what is the total time? T1 alpha by alpha minus 1. You take this is my equation number 4. That is the total time. Now we are finding total displacement. Now we are finding total displacement. So how is the diagram once? For finding that once you check the diagram. That is like this, continuous going like this. So here, what you are given first one? U naught given, here this theta given. This I have taken horizontally, I am taking this horizontal velocity U1. I am taking this time of flight T1. This time of flight T2. This horizontal velocity U2. Here I had given only U naught and here again what? U naught by alpha, U naught by alpha square like that given, not 2 alpha, alpha square. Next one is u naught by alpha square given. What you are given that only right. If h is 2 alpha, 2 alpha right, no problem. Now, in a parabolic path, what constant? Horizontal velocity constant. We want to find horizontal displacement only, no vertical height. So, horizontally what having? In the parabolic path always uniform velocity. So, velocity into time gives what? Displacement. So, this displacement I am taking x1, this I am taking x2, like that you take. Then what happens? Total displacement. Total displacement. That I am taking as s. Velocity into time. Here to your how much time taking? Time of flight, t1. So, this is u1 t1 plus u2 t2 plus u3 t3 dash dash infinity up to that. Now, already we have taken one relation. What is that here? T1 by alpha, T2 by alpha, like the time happens. But what about U1, U2 relation? We don't know. That I am taking. So, for the purpose, time this only, T1, T2 like that, total time. We are using this again. U1 I want to find. If this is U0, if this is U0, for example, if this is U0, it is making theta angle, then according to resolution of vectors, what happens is U0 cos theta, and what about this? U0 sin theta. But here U0 cos theta equal to what we have taken? U1 taken. So, U1 equals to U0 cos theta, angular projection. Similarly, that you take again. U1 equals to U0 cos. Second case you take. U2. What about U2? U0 by alpha. U0 by alpha into angular projection same only. Angle of projection, angle of rebounds, all are same only. Every up to infinity. So this is U into cos theta. So this U0 cos theta I am taking as U1. So U2 equals to what happens? U1 by alpha. If it is 2, 1 alpha. Similarly, next what happens? U0 by alpha square happens. So U3 what happens? Additionally alpha square comes, remaining same. So U1 by alpha square comes, like that it is going. So this is happening. I know T1 conditions, I know U2 conditions. U into T gives what? Displacement. These all displacements adding, I am getting total displacement. U1, T1 like that things. Okay, now to substitute all the values. Total displacement. This implies total displacement that equals to U1, U1 only, T1, T1 only. Second time what happens? U1, U2. But U2 what happens? U1 by alpha. Now only we have derived this. The second one what? T1 by alpha. T1 by alpha. Next what happens? U1 by alpha square. U1 by alpha square. Here T1 by alpha square. Like that it is going. That is the total displacement. Now, this is total time. We want to use this. Now, what I am taking? S equals total displacement. I am taking U1 T1 comma. What I am getting here? 1 plus 1 by alpha square plus 1 by alpha power 4 up to dash dash infinity. That is the total displacement. Now, this also infinity GP. Now also you compare. Already we had compared previously like that. What is the formula for GP AR square up to dash dash infinity? This is called GP. Compare. A equals to 1. Or what is the ratio? That equals to 1 by alpha square by 1. Again I am getting 1 by alpha square. Similarly 1 by alpha by 4 by 1 by alpha square. Same I am getting 1 by alpha square. These two must be same. We know that one. Mathematics process GP. Now you go to formula. What is the formula for S infinitive? That equals to A by 1 minus R. Now what is the A? 1. R value, that substitute. Then what I am getting? Total displacement. This implies total displacement U1 T1 into what about this total value? A by 1 minus R. A equal to 1 by 1 minus R. 1 minus R. R equals to 1 by alpha square. Now what is the total displacement? U1 T1. Now you go to LCM alpha square 1 by alpha square minus 1. Now this implies what I am getting here? S1 equals to U1 T1 into alpha square by alpha square minus 1. This I am taking as equation number 5. Total displacement, total time. That gives the average velocity. So it equals to total displacement by total time. Otherwise resultant displacement by total time. Now I am finding average velocity. Now I am finding average velocity. Therefore, average velocity, that equal to total displacement or resultant displacement by total time. Total displacement by total time. That is called average velocity. S1 by T, that equals to S1 by T. Now substitute all the values. What is the S1? This implies S1 equals to U1 T1 into alpha square by alpha square minus 1 by time. T1 alpha by alpha minus 1. That is the total time. Okay, now this mathematics we are doing. U1 T1 alpha square by alpha square minus 1 by total time. What is the total time? T1 alpha by alpha minus 1. So that mathematics we are doing. This is average velocity. So this I am taking as velocity, VUT. U1 T1 alpha square by alpha square minus 1 into alpha minus 1. This happens. Now what happens is V equals to U1 T1 alpha square by alpha square minus 1 into alpha minus 1 by T1 alpha. Here T1 cancel, alpha cancel. Alpha square minus 1 again I am writing as 1 square. A square minus B square equal to A minus B into A plus B. That formula again I am applying. Now, this implies average velocity equals to u1 alpha into alpha minus 1 a square minus b square, a minus b into a plus b. This cancel. Which formula applying here? Since a square minus b square, that equals to a minus b into a plus b. That formula I am applying. Finally, what is the average velocity? u1 alpha by alpha plus 1. This is my equation number 6. That is the average velocity. That is average velocity. u1 alpha by alpha plus 1. Correct. Next, what you are given actually, this average velocity equals to 0.8 v1. Actually, this average velocity equals to 0.8 v1. This v equals to 0.8 v1. Condition given that v equals to 0.8 v1. Here given condition. So that equals to u1 alpha by alpha plus 1. Here, what is the v1? In the first parabolic path, average velocity. What is given? In the first parabolic path, average velocity is called v1 given. In the first parabolic path, what is this first parabolic path? This is like this. What is the velocity? u0 velocity. What we have taken here? Angle of projection theta. Total time what we have taken? t1. Time of flight. What we have taken? Original velocity? u1 taken. So in this duration, average velocity is v1. What is the formula for average velocity? Total displacement by total time. I want v1. How it comes? Average displacement. This I am taking x1 by total time. Time of flight t1. Here what is the displacement? Horizontal velocity u1 into time t1. So now this I am writing as, what is the total displacement from here to here? u1 t1, because in the parabolic path horizontal component constant. So u1 t1. Velocity into time gives displacement. Uniform velocity only. Otherwise s equals to u plus alpha d square formula you apply if it is having acceleration by time t1. So u1 I am getting. What is the u1? In the first duration, average velocity. Again you substitute that value. Now substitute. This implies 0.8 into v1. What is the v1? u1. That equals to u1 alpha by alpha plus 1. u1 cancel. Now what I am getting here? 0.8 equals to alpha by alpha plus 1. Now you go to cross multiplication. Alpha equals to 0.8 alpha plus 0.8. Otherwise alpha minus 0.8 alpha equals to 0.8. One minus 0.8. We are getting 0.8. So this implies 0.2 alpha, that equal to 0.8. These two remove it. So 2 alpha equals to 8. Otherwise alpha equals to 8 by 2. So I am getting alpha value 4. So this is the answer to this question.